Good morning, everyone. Yeah, very good morning. Shall we begin the session? Yes, today's topic is the views of the data. Yes, in the last class, we have started with the revision of the database design concepts, and the next topic is views of data. So, database is a collection of the data or the collection of the interrelated data and a set of the programs that allows users to access and modify these data. And the major purpose of a database system is to provide users with an abstract view of the data. That is, a system hides certain details of how the data are stored and maintained, how it is occupied, how it is maintained, how it is done. So first part is data abstraction. So for the system to be usable, it must receive the data efficiently, and the need for efficiency has led the designer to use a complex data structure to represent the data in the database system. And many database systems also use the computer trained devices complexity from the user through several capacities that is available through level. So first part is the data abstraction that is used to make the database for the system to be usable. It must retrieve the data efficiently, and the need for efficiency has led the designer to use a complex data structure to represent the data in the database. And since many database system users are not computer trained, so there is a complexity from the users to several level of the abstraction to simplify users' interaction with the system. Now first is a physical level. So this is the lowest level of the abstraction that describes how the data are actually stored. And the physical level describes the complex row level data structure in the detail. The next is a logical level that describes what data are stored in the database and what relationship exists among these data. And the logical level therefore describes the entire database in terms of a small number of relatively simple structure, and all the implementation of the simple structure at the logical level may also involve the complex physical level structures. So the users of the logical level does not need to be aware of the complexity. This is referred as the physical data independence. And database admin who must decide what information to keep in the database also uses the physical level or the logical level. So physical is how and logical is what. The view level is highest level of the abstraction that describes only a part of the entire database. Even though the logical levels uses simpler structures, so complexity remains because of the variety of the information stored in a large database. And many users of the database system do not need all this information. Instead, they need to access only a part of the database. So they are only accessing the part of the database. And the view level of the database exists to simplify their interaction with the system. The system may provide many views for the same database. So figure this one shows various databases. So there are multiple views. This is the logical level, then physical level. These are the three levels of the data abstraction. This is a type instructor equals to record ID char 5, name char 20, department name char 20, salary 82. That means 8 is a integer part and 2 is a decimal part. And this code defines a new record type known as an instructor with the full field, and each field has a name and the type associated with it. And there's a university organization. We have several such record types, including the department, course, student. Department has a various fields like department name, building, budget, course, that is a course ID, title, department name, credits, then student, ID, name, department name, and the total credit. And at the logical level, each record is described by a type definition as we are using in the previous code definition, and the interrelationship of these record types as defined as well. And whenever a programmer using a programming language work at this level of the abstraction. And similarly, database admin usually work at this level of the abstraction. Finally, at the view level, computers see the various application programs that hides the details of the data types. And at the view level, several views of the database are also defined. And database users might use with the logical level of the abstraction with the database. The views also provides a security mechanism as to what to prevent or how to use from accessing the certain part of the databases. For example, the clerks in the university, the registrar office can see only the part of the database and information about the database. They cannot access the information about the salaries to the instructors. The next part is the instance and the schemas. The database changes over a time as information is inserted and deleted, and the collection of the information stored in the database at a particular moment is known as the instance. So this is at a particular moment when the database is stored. And the overall design of the database is known as the database schema. And schema are changed infrequently at all. This is change infrequently at all means whenever it is free, that is available at all the times. And the concept of database schema and the instance can be understood by the analogy to a program that is written in a programming language, and database schema correspond to the variable declaration that is used or that is associated with the program that is used with the program or to the variable declaration, and each variable has a particular value at a given instant. And the values of the variable in a program at a point in time correspond to an instance of the database schema that have multiple schemas, several schemas that is defined at the physical level, logical level, as well as the sub-schemas. Now, when we talk about the physical schema and the logical schema that is used with the instance schema, and the database system has several schema partitioned according to the levels of the abstraction. And the physical schema describes the database design at the physical level, while the logical schema describes at the logical level. So both are available, partitioned into two parts. And database also have several schemas at their view level, sometimes known as sub-schemas, that describe the different views of the database. And of this, the logical schema is by far the most important in terms of its application program, because when you say about the logical schema, that means how it is done, not the word. And the physical schema is hidden beneath the logical schema and can usually be upgraded, can usually be changed without affecting the application program. And they are said to exhibit the physical data independence if they do not depend on the physical schema, and therefore not to be rewritten if the physical schema changes. Next is the data models, that is a collection of the conceptual models, that is tools for describing the data, for using the data relationship, data semantics, and consistency constraints. And data model also describes or provides a way to describe the design of the database at the physical, logical, and the view level. That is, underlying the structure of the database is the data model. That is a collection of the conceptual tools for describing the data. And there are a number of different models, data model, that we are using out, that we shall cover in the text. And the data model can be classified into four categories, four different categories. One is a relational model. That is, the relational model means everything is available within a relation, that is within a table. So table is a collection of the rows and the columns. So a relational model is a collection of the table to represent both the table, both the data, and the relationship among the data. That is the relational model. And each table have a multiple columns, and each column have a unique names. And table are also known as the relation in the case of the relational model. That is an example of the record-based model also. And these models are so named because the database is structured in a fixed format record of the several types. Then entity relationship model, that is an ER model, that describes or uses the basic concept or the collection of the basic concepts known as the entities relationship among these objects. An entity is a thing or object in the real world that is differentiated from the other objects also. The next one is object-oriented or object-based data model, that includes a C++, that is included in the Java, that becomes a dominant in case of the software development methodology, and this led to the development of the object-oriented features also, that can be seen as extending the ER model with the notation of the encapsulations, methods, and the object entities. Then semi-structured data model, that permits a specification of the data where the individual data types or items of the same type may have a different set of the attribute. This is in contrast to the data model mentioned earlier, where every data item of a particular type must have the same set of the attributes. And the XML is widely used to represent the semi-structured data that includes a network data model or the hierarchical data model that provides a relational data model. The next one is the database languages. This is one of the main concepts. One of the system or one of the database system provides a data definition language. So one of the language is the DML or the DDL. One is the data definition language, one is the data manipulation language. DDL stands for data definition. As the name advises, it works on the structure, and DML works on the internal data record that specifies the or express the database queries and updates. And in practice, the data definition and the data manipulation languages are not two separate languages. Instead, they simply forms a part of the single database language, such as a widely used SQL language. So it's the SQL language that is widely used for the data. So first one is data manipulation language. This is a language that enables the users to access or manipulate the data as organized by the appropriate data model. So that means it is a language that defines how the data will be used, how the data will be manipulated by the appropriate data model, and the types of access are retrieval of the information stored in the language or database, insertion, so retrieval, insertion, deletion, and at last there is a modification. Retrieval in the sense fetching the data from the database, then insertion means inserting the new rows, deletion means deleting the already records, then modification means changes in the records. So these comes under the DML. So retrieval, insertion, deletion, and the modification. And there are two types basically of this. One is a procedural DML, one is a non-procedural, that is also known as the declarative. So procedural DML also requires a user to specify what data are to be needed and how to get it. So what is the data that is required and how to get it. The next one is a non-procedural DML that also requires a user to specify what data are needed without specifying how to get it. So that means procedure means what to get it, non-procedure means what and how to get it. Okay, yes. Procedure means what and how, non-procedure means what but not how. So what how in procedure and what but not the how in non-procedure, that is a declarative. In this terms, there is a part that is a query. This is a statement or the condition that applied that requesting the retrieval of the information. For example, select star from employee. This is the query that is used to fetch the data from the database. So this is a statement requesting the retrieval of the information. And the portion of a DML that involves information retrieval is known as a query language. Although technically correct, it is the common practice that to use the terms query language and the DML language synonymously. Yes, synonymously. Why synonymously? Because query language and DML are the same, and there are a number of the database query languages in use either commercially or experimentally, that is used with the wide standard with the query language SQL, and the level of the abstraction that is used may not to apply to define or structure the data, but also to manipulate the data. And at the physical level, we must define the algorithms that also allow the efficient access to the data. And high level of the abstraction, we emphasize ease of the use, and the goal is to allow the human to interact with the system. Next one is a DML, or sorry, DDL, that is a data definition language that is to specify the additional properties of the data. One is the internal properties, one is to specify the external properties or the additional properties. That is also known as a database or the data storage and the definition language. And whatever the data value that is stored in the database must satisfy the certain consistency constraints. For example, suppose the university requires account balance of a department that must be a negative, or that must never be a negative. So DDL provides the facility to specify such constraints, and the database system checks these constraints every time when the database is updated. And in general, a constraint can be arbitrary predicate pertaining to database that is defined in the test with the minimum overheads. So first part is the domain constraint, then differential integrity, then assertion, authorization, authentication. Now next is the relational database. This is the main concept. So when we talk about the domain constraint, that means we are combining within the domains, that is the possible values that is associated with every attribute with various defined, for example integer type, char type,
date time type, and declaring an attribute to be of one of the kind that also act as a constraint on the values it can take, and the domain constraint are the most elementary form of the integrity constraint. That means we are taking the domain, we are taking the group of the values and makes a constraint that is known as a domain constraint. And they are tested easily by the system whenever a new data item is entered into the database. Then next one is, yes, domain constraints are most important or elementary than the integrity constraint. Then these are tested or easily by the systems whenever a new data item is entered in the database. The next one is a referential integrity. So there are the cases when we wish to ensure that the value that appears in one relation for a given set of the attribute also appear in the certain set of the attribute in another relation. That means one value becomes the attribute for the another value. That is known as a referential integrity. We are maintaining the reference, we are maintaining the relationship. That is known as the referential integrity, and database modification can cause violation of the referential integrity. And when a referential integrity constraint is violated, the normal procedure is to reject the action that caused the violations. The next one is the assertions, that is any condition, any scenario that the database must always satisfy. And domain constraints, referential integrity constraints are special forms of the assertions. However, there are some other constraints also that we cannot express by using these special forms. For example, every department must have at least 5 courses offered every semester. That must be expressed as an expression, that must be expressed as a condition. And whenever an assertion is created, the system tests for the validity. What type of validity? Whether it works, whether it works, whether it is up to the mark of the users, or whether it satisfies the needs of the users. And if it is valid, then any future modification to the database is allowed only if it does not cause that assertion is to be violated. Assertion is violated, assertion is going on, that is also covered within the database. The next part is the authorization, and we may also want to differentiate among the users as far as the type of the access they are permitted on the various data values. These differentiations are expressed in terms of the authorization. And the most common is read authorization, that is only provided for the reading part, not for the updation, not for the deletion. That is only allows reading but not the modification. The next is insert authorization, that allows insertion of the new data but not modification of the existing data. That means we are going to insert the new data, but we cannot modify the existing data. Then update, that only allows modification but not the deletion. Modification in the sense changes, any changes. For example, name has been changed, field name has been changed, table name has been changed. That is a modification in the data but not the deletion. Then next is delete authorization, that also allows the deletion of the data. Not modification, nothing. Simply deletes the data. And we may assign the user all, none, or a combination of these type of authorization. That means we are going to provide the facility, we are going to provide the privilege with one of the users, with multiple users, with any of the users. So that is the authorization. That includes read authorization, insert authorization, update authorization, and delete authorization. These are the 4 parts of the authorization that is expressed in terms of the data value, that is expressed in terms of the database. Yes. And DDL, just like any other programming language, gets as input some instruction statement, generates some output. And the output is placed in a data dictionary, which contains some metadata, that means data about the data. For example, if I'm talking about a machine or the table, that also shows the database of the employee. That's the data dictionary, and the output of the DDL is placed in the data dictionary, which contains metadata, that is data about the data. And the data dictionary is considered to be a special type of the table that can only be accessed, updated by the database system itself, not a regular user. And the database system also consults the data dictionary before reading or modifying actual data. So before reading or before modifying, we are using the actual data, we are using a regular user, that is covered in the database system's privilege, that is used within a special database that is used within a special privilege of the users. Yes, the database system also consults the data dictionary before reading or modifying the actual data. Now the next part is relational database that I'm going to start within the next class, that is in the tomorrow's class. That is what is a relational database, what is the relation, what is a table, another name is relation, rows another name is tuples, then attributes, whatever. That is the relational database that I'm going to start within the next class, that is in the tomorrow's class. So till now, any doubts anyone? Any doubts anyone in the assignments? Any doubt anyone in any of the topic? Yes, if you have any doubt, then please clarify the doubts with the chat, with the yes online, that is a phone. Again, I'm asking, any doubts anyone? Yes, I'm going to start with the relation database in the next class. All right. So thanks a lot, everyone. Bye bye.